Welcome back to Inquisitive Kids. On this channel, our goal is to help you discover a love for mathematics and to level up your understanding in mathematics in one way or the other. So this is chapter 12 of our 8th grade math course, where we will be giving you an introduction to fractional expressions. Explore the concept of fractional expressions. Fractions is something that you have definitely encountered before, and so are whole expressions. Whole expressions is something we learned in 7th grade, so for a review on that, I will be attaching its link in the description down below. But as we go through this lesson, I want you to think about the parallels it has with whole expressions and fractions. Discovering fractional expressions, Part 1. Part 2 will be the properties of fractional expressions. So if you don't want to miss out on that, be sure to click the notification bell as well as the subscribe button. Fractional expressions are another type of algebraic expression similar to whole expressions, but with some differences. Today, we will understand the concept of fractional expressions and understand and find the conditions under which a fraction is meaningful and the condition under which a fractional expression is 0. Let's fill in the blanks. Karen is running the 100-meter dash. If Karen's speed is 7 meters per second, then what is the total time it takes for her to finish the race? If Karen's speed is a meters per second, where a is the variable, then what is the total time it takes for her to finish the race? And if Karen's original speed is a meters per second and improved her speed by 1 meter per second through training, then now her time would be blank s. Now pause the video and try to use the distance, time, speed formula to help you solve. Since we know that this is a 100-meter dash, her time would be 100 divided by 7. And since now we're just swapping out the 7 for a, her time would be 100 divided by a. And since she improved her speed by 1 more meter per second, her speed would be a plus 1, which means that the expression would be 100 divided by a plus 1. Now there's some more blanks. The teacher pours water with a volume of 200 centimeters cubed into cylindrical buckets with a base area of 33 centimeters squared. The height of the bucket is blank centimeters. If an amount of water with a volume of V is poured into a cylinder with a base area of S, then the height of the water is blank. 8 bags of chips cost $8. 1 more ice cream costs B dollars. The total cost would be blank dollars. Again, pause the video and try to solve. So the first one is just using the volume formula for cylinders. The first blank should have been 200 over 33, and the second one should have been V divided by S. Now since it's 8 bags of chips plus 1 ice cream, that would be 8A plus B dollars. Now let's look at the concept of fractional expressions. Classify the expressions from the previous questions into categories. So all I want you to do is just observe their properties, their differences, and their similarities. Whole expressions are something that we have learned before. There are 2 types of whole expressions, monomials and polynomials. An example of a monomial would be 100 divided by 7, 200 divided by 33, and an example of a polynomial would be 8a plus b. Whole expressions also cannot have variables on their denominators, so that's part of the definition of whole expressions. Again, if you need some extra review on that, I strongly suggest you to go into the description and review the lesson that we did earlier on whole expressions. But there are also some expressions that are neither monomials nor polynomials, so expressions that are not whole expressions, which is 100 divided by a, 100 divided by a plus 1, and v divided by s. Out of these expressions, what are their similarities and differences? Well, here are their similarities. They are all in the form of f divided by g, where the numerator f and denominator g are both whole expressions. But here are their differences. We need to observe their denominators. Not all of them have variables on the denominator. Some do, some don't. And the ones who do are not whole expressions, as we saw on the last slide. So here is our knowledge key point. Definition of fractional expressions. Usually a and b represent two whole expressions. A divided by b can be expressed in the form of a divided by b, in this fractional form, and b contains variables. Remember, if it is a fractional expression, b must contain variables, which is the denominator. We can call a over b a fractional expression. A is the numerator, while b is the denominator, which cannot equal 0. So out of this definition, here are some important points to think about. Fractional expressions are also algebraic expressions. Fractional expressions are the quotient of two whole expressions written in the form of a divided by b, where a and b are both whole expressions and b contains variables. And finally, a is the numerator of the fractional expression and b is the denominator. So on slides like knowledge key point or conclusion or something like that, or method summary, these are usually good times to pause the video and take some notes, just in case this is your first time going through our course. So this would be a good time to pause the video and take some notes. All right, all of the information from the lesson will always be concluded in the class summary slide at the very end of the lesson. Anyways, let's do some more thinking. What are the connections between fractions and fractional expressions? Well, let's look at 100 over 7. It's a whole number, and the numerator, 100, is a whole number, and the denominator, 7, is also a whole number. For 100 over a plus 1, which is a fractional expression, the top is a whole expression, and so is the bottom. This is where our analogical thinking comes in. Fractions are the result of the variables in fractional expressions taking certain values, and fractional expressions are more general. The thing between fractional expressions and fractions is that in a fractional expression, the denominator must contain variables. But say in this fractional expression, a equaled 6. That would be equivalent to 100 over 7, right? So this is what it means when fractions are really the simplified results of fractional expressions. Fractions are what you get after you substitute the variables in fractional expressions for a known number. So this is our specific to general thinking. We're looking at one specific area of mathematics and then connecting it to something more general. Since fractional expressions are another type of expressions different from whole expressions, what can they be collectively called? So here we have a diagram, and as you can see, these are the shared properties of expressions and numbers. We have whole numbers and we have whole expressions. The fractions are sort of related to whole numbers, and the expression form of fractions are fractional expressions. On this side, we have rational numbers, while here we have rational expressions. In elementary school, this left side has been what you've been mostly working with, while on the right side, this is more of what we've been learning throughout 7th grade, throughout 8th grade. Just these middle school terms and concepts and definitions are mostly from the right side of this diagram. But here you can really see how one part is connected to another, how they have a relationship with another in the way that they are arranged. For example, whole numbers and fractions are on one side, whole expressions and fractional expressions are on the other side. Whole numbers and whole expressions are on the same row, while fractions and fractional expressions are on the same row. And now you see the differences: rational numbers and rational expressions, which means that there will be irrational numbers and irrational expressions, but right now that's too complicated for our level, so that's something we will get to later. Which of the following are fractional expressions? Use the notes of the definition that you have taken earlier to help you solve this problem. Pause the video and try to determine it by yourself. So here is the answer. The fractional expressions are 3000 divided by 300 minus a, v divided by s, 4 divided by 5b plus c, and x squared minus xy plus y squared divided by 2x minus 1. Here is our conclusion. 1. When determining, remember that expressions containing pi are constants. Since pi does not look like a normal numerical Arabic numeral, people sometimes just, their brains might think that pi is a variable, but remember, pi is a constant number. And 2, if there are multiple terms, if one of the denominators contain variables, it is also a fractional expression, such as 1 plus 1 over a. As long as one term in that entire expression contains variables on its denominator, it is a fractional expression. Now let's look at the conditions for the fractional expression to be meaningful. We know that to make fractions meaningful, the denominators in the fractions cannot be 0. To make fractions meaningful, what conditions should the denominator a divided b meet? So, what does it mean to be meaningful? Well, that just means in mathematics that an expression has a value that exists, right? If you have, say, 1 divided by 0, you probably already know that you can't divide anything by 0. In mathematics, that's just not something that exists. So that's what we mean by it not being meaningful. And now, since we are starting to have variables on the denominators, there are some conditions that we have to rule out first to let you understand when a fractional expression is meaningful. Because when denominators have variables, that just allows a lot of different possibilities to exist. So in the form a divided by b, since b is the denominator and when it equals 0, a divided by b is meaningless. When b is not equal to 0, this expression is meaningful. So here, instead of meaningless, it should be meaningful. Here's question 3. Given, let me first write this out for you. Given x squared minus 4 divided by x plus 2, when x is divided by 3, what is its value? When x is equal to 3, its value is 3 squared minus 4 over 3 plus 2, which is equal to 1. Now here is our next question. When x is equal to negative 2, what is its value? When x is equal to negative 2, the expression has no value, since when x is equal to negative 2, it will make the denominator equal 0. And that just means that it has no value, it does not exist, and it is meaningless. What is the value range of x so that the fractional expression here is meaningful? What conditions must x meet so that the fractional expression is meaningful? When x blank, the fractional expression is meaningful. Well, since back here on this slide, we said that when the denominator does not equal 0, then we can use that and say when x does not equal negative 2, the fractional expression is meaningful. So when we are answering the first question, we are using general to specific thinking. So the opposite of specific to general thinking. We're thinking about something that's general and then putting a specific value into it. So turning it from something more general and connect it with something more specific. So here is example 1. When a is equal to 1, 2, and negative 1, find the value of a plus 1 over 2a minus 1. And 2, what is the value range of a to make the expression meaningful? Pause the video and try to solve this on your own. Well, for the first question, all we have to do is substitute in the values of a. So when a is equal to 1, the fractional expression is equal to 2. when a is equal to 2, it's equal to 1, and when a is equal to -1, the fractional expression is equal to 0. When the denominator equals 0, the fractional expression is meaningless. So what could be the value range of a? Well, we don't want the denominator, which is 2a minus 1, to equal 0. So a cannot be equal to 1/2. So when a is not equal to 1/2, the fractional expression is meaningful. Here's example 2. Given that x minus 1 over x minus 1 times x minus 2 is meaningful, then the value range of x is blank. Now pause the video and find the multiple choice answer. So let's look at A. X does not equal 1. Well, if x does not equal 1, it could still equal 2. And if it's equal to 2, you'll see that the denominator will still be 0. For B, if x is only not equal to 2, it could be equal to 1, so vice versa, which means that the answer should have been C, since both x is not equal to 1 and x is not equal to 2. So here is our method conclusion. A fraction is meaningful if the denominator is non-zero. If the denominator is in the form of a product of several factors, also in factored form, then each factor has to be non-zero. This is where you have to really split up your thinking into this scenario and that scenario. Practice. So there are 5 blanks that you have to fill in. So when x is blank or when a variable is blank, you have to give in the condition that fractional expression is meaningful. Pause the video and try to fill in the blanks on your own. The first one would be when x is not equal to 0, when x is not equal to 1, when b is not equal to 5 divided by 3, when x is not equal to y, and when x is any real number. If x is equal to 0 for the first question, then the denominator would be 0. If x is equal to 1, then the denominator would be 0. So we don't want x to be equal to 0 or 1. Same thing for the rest of these. And here, when x is not equal to y. So this is another type of condition that you can have when the relationship between two variables. If x and y are the same value, then you'll see that it'll be x minus x or y minus y, and the bottom will be 0. So x and y cannot equal each other. This is what you need to really think about when you have two variables on the denominator. And for the fifth one, what type of number is x? So when x is any real number, this will be meaningful. What conditions must f and g, the numerator and denominator of this fractional expression, meet to make the value of f divided by g equal to 0? Well, when f is equal to 0 and g is not equal to 0, f divided by g has a value of 0. So now we're looking at the conditions of when a fractional expression equals 0, because this is a special case. Here is example 3. What value must x take to make x squared minus 1 over x plus 1 equal to 0? Well, remember, in order to make a fractional expression equal to 0, the numerator must be equal to 0, while the denominator is not. So we want x squared minus 1 to equal 0, so therefore x can be equal to positive or negative 1. But there is a second step to this. But remember, we don't want the denominator to equal 0, because if it did, then the value would not exist. So x plus 1 cannot equal 0. So x cannot equal negative 1. So we already narrowed down the options of the value of x to be positive or negative 1. And now that we know that it can't be negative 1, x must be positive 1. So when x is equal to 1, the fractional expression is equal to 0. Step up training. When blank, the absolute value of x minus 2 over x plus 2 is equal to 0. Here's our analysis. For a fraction to have a value of 0, only the numerator is 0 and the denominator is not 0. Therefore, if we write this into the form of a system of equations, solve x is equal to 2. At first, if you just solved the first equation, you would have answered with x is positive or negative 2. But then you realize that x cannot equal negative 2, which means that x must equal positive 2 and only positive 2. So this is what it's like in a lot of mathematics problems. You can't just look at one equation, get a conclusion, and assume that is the one. You also have to think, does this also match this? Does it match that? Does it match every single condition I need in order to have the answer? So when x is equal to 2, this fractional expression is equal to 0. If the absolute value of x minus 3 over x squared minus 2x minus 3 is equal to 0, then what does x equal? Again, using the same strategy, pause the video and solve. The answer would be negative 3. Here's our analysis. The value of the fraction is equal to 0. The numerator should be equal to 0, and the denominator should not be 0. So all of this text written in the form of a system of equations, we can solve, and we have x is equal to negative 3. Example 4. What is the value range of x to make x minus 2 over 2x minus 3 not exist and equal to 0? Not exist just means meaningless. So using the conditions that we've just learned, pause the video and answer the question. All right, so first, for the first question, not exist. When x is equal to 3 halves, it'll mean that the denominator is equal to 0. So therefore, when x is equal to 3 halves, the fractional expression doesn't exist. And what if we wanted to make it not equal to 0? Well, now there's two conditions. First, the numerator has to equal 0, and second, the denominator cannot equal 0. So x minus 2 has to equal 0, and 2x minus 3 is equal to 4 if x is equal to 2. And 4 is not 0, which is good. So this way, the value of x minus 2 over 2x minus 3 is 0. Example 5. Find the value of x minus 5 over x plus 6 depending on the conditions given. X is equal to 3 and x is equal to negative 0.4. So just substitute in the values of x. When x is equal to 3, the fractional expression can be simplified into negative 2/9. And when x is equal to negative 0.4, the fractional expression equals negative 27 over 28. So here is our one final practice problem. Fill in the blanks of this table. All you have to do is substitute the value of x into the fractional expression. Well, after filling it in, this is what it should look like. Class summary. So this is the class summary page that I was mentioning earlier on, and this is usually a good time to pause the video and take some notes. As you will see, this slide is split up and organized so that it's easy for students to copy down and have a visual mind map of what we've learned today. So today we learned all about fractional expressions. Its definition is a whole expression, f divided by a non-zero whole expression, g, where g contains variables, with a quotient of f over g. Condition of meaningfulness. To make the fractional expression f over g meaningful, g must not equal 0, so the denominator cannot equal 0. And if we want the conditions to equal 0, there's actually two conditions. To make the fractional expression f over g equal to 0, f has to be equal to 0, and g cannot equal 0. Again, pause the video if you need to take some notes. Here is our lesson summary. Today we understood the concept of fractional expressions, and we understood and was able to find the conditions under which a fraction is meaningful and the condition under which a fractional expression is 0. So the next lesson coming up will be all about the properties about fractional expressions, where we will be seeing more parallels with fractions and whole expressions. Again, if you enjoyed this video or if you learned something new, click that like button, and thank you so much for watching 3 Inquisitive Kids. My name is Karen, and I'll see you next time.